Now in section 3.4, we're going to deal with some of the age-old questions that students always ask. So when you get a test back in a class, having been a teacher for a while, one of the first things students ask you is, what was the average? Reasonable. But then they want to know what their grade was, right? Because what they really want to know is, how did I do in comparison to the rest of the group? So let's do a little thought exercise. Suppose you get an exam back and you find you got a 70%. How do you feel about your score? Well, you passed, so that's good, but in general, most students, not too great, because 70% is the lowest passing grade possible. Oops, passing. I can spell. All right. Now suppose I further inform you that the mean on this test was 60. Now how do you feel? Well, better, because at least I know that I scored better than half the class, roughly. It's not a median, it's a mean, but still, you know that you're better than most of the people, all right? Now suppose I tell you that the standard deviation was 10. Matter of fact, is what I'm going to write. So I only scored one standard deviation above the mean. Now you probably want to know how I got that. Well, you take what you scored minus the mean, you take the whole thing, and you divide it by a standard deviation, right? So 70 take away 60 is 10. 10 over 10, last time I looked, was 1. That's where I'm getting that from, right? So if you score one standard deviation above the mean, that's not great, right? So here's the work. I can just show you that, right? That isn't super great. It's okay, right? But now suppose I tell you that instead I was wrong and the standard deviation was 5. Let's think about that. What would that mean for this value? Instead of dividing by 10, you'd divide by 5, which would mean you're 2 standard deviations. Now remember, we learned way back in section 3.2 that being 2 standard deviations, oopsie, I can spell this, deviations above the mean is unusually high. So now I'm feeling much better about my score of 70. Now I grant you it's still just a barely passing score, but at least I know I did really well in comparison to the rest of the group. I mean, if you're that kind of mean person that's always, trying to compare yourself. Just kidding. All right, so what we've just done is z-score calculations. I hope you enjoyed them. They were enjoyable for me too. All right, so I got to get these. There it is. So now I've got the box on there. All right, so we've just done our first z-score calculations. Now you can do z-score with population data or with sample data. It works the same way. You take your value minus the mean and you divide it by the standard deviation. It's unitless. It has a mean of 0 and a standard deviation of 1, because if you scored the mean, take the mean minus the mean, you'd get 0, right? All right, so this, by the way, is going to come back to haunt you in a big old way in chapters 7, 8, 9, 10, 11, right? We use z-scores a lot in those chapters. So this is going to come back, dun, dun, dun. Much like Arnold Schwarzenegger. It'll be Bach. All right, so let's find some z-scores and see what they're good for. So the mean height of males 20 years or older is 69.2 inches with a standard deviation of 2.9 inches. The mean height of females 20 years or older is 64 inches with a standard deviation of 2.75 inches. So Steve is 6'4", Alana is 5'9", who is relatively tall. Now we know Steve is taller because 6'4" is higher than 5'9", but who is relatively taller. So the first thing we're going to do is we're going to find Steve's height. So Steve is 64 inches, or excuse me, 6 feet, 4 inches. There we go. Which would be equal to, now 6 times 7, or excuse me, I'm sorry, 6 times 12 is 72. 72 plus 4 makes 76 inches. Okay. So then we're going to find his z-score. His z-score, in fact, I'll say it for Steve, is equal to, so you take his height, which is 76 inches, minus the mean, which was what was it for guys? 69.2. 69.2, and we divide it by 2.9. And you're going to get what his z-score is. Now I'm going to make the Excel do this for us because, we've got it. So this is 3.4, example 1. Okay. So we got Steve, right? His height was 6 feet 4 inches. Okay. So then I figured out height in inches was equal to 6 times 12, because there's 12 inches in every foot, plus 4, which made 76. Then we said the mean was equal to 70, oh crap, 69? What was it again? Yep, 69.2. 69.2. And the standard deviation was equal to 2.9, if I'm not mistaken. Oops, not that way. That way. There we go. 2.9. All right, I'm going to go type it up for Alana as well. Hold on one second. All right, there, I've got them both. Now I can find the z-score two ways. I'm going to find it both ways. So the z-score I could find by taking that formula. So you take your value, 76, minus the mean, which is 69.2, close your parentheses, divide by 2.9. There you go. There's another way to do it. Let me z-score a second way. Would be equal to, and there's a function, it's called standardize. Oops, standardize, see it? I can just click on it. Oh, if I would actually do it. There. And it's going to say, what's your x value, comma, your mean, comma, your standard deviation. My x score was 76, comma, the mean, 69.2, comma, standard deviation. Boom. There we go. So it found it that way too. So whichever way you like, they're both good. The advantage to doing it this bottom way, well, they're both kind of good, because what I can do is copy and paste, and it finds it for both of them. So I'm going to make poor Steve here. I'll go with gender roles and make him blue, and I will make me, because I'm Alana, pink. If I could find me a pink color. There we go. All right. So I found it with the standardized way or with the actual formula. They both work. It's all groovy. All right, so the z-score for Alana and z-score for Steve. So I'm going to put these in. So this one was Steve, and this one was Alana. All right, now who is relatively taller? Steve is relatively taller because he has a higher z-score. As a matter of fact, Steve is unusually tall. Right? All right. As a matter of fact, Steve is unusually tall because he is more than 2 standard deviations above the mean. Boom. All right. What we've done is turn these into standard scores, i.e. standardized scores. That's why Excel calls them standardized as the function. What does that mean? Well, by making them both into z-scores, we are able to compare two unlike populations, such as males and females, or SAT scores and ACT scores, that kind of thing, right? Standard scores put everyone on an equal footing, if you will. All right. Now, Yao Ming was a center from China for the Houston Rockets for many years. He was 7 feet 6 inches tall. What is his z-score? Explain what that means for him. Well, luckily for me, I've got a handy-dandy little thing here, so I'm going to copy and paste. I'm going to type Yao Ming. Okay, he was 7 feet 6 inches tall, or is, I should say. All right, that's equal to 7 times 12 plus 6. There we go. There's his z-score, 7.17. I'm going to make him red for the Houston Rocket color. There he is. All right, so Yao Ming's score, z-score, is right there. Okay, so Yao Ming was, or is, I should say, is 7.17 standard deviations above the mean. He is very unusually tall, right? All right. Hypothetically speaking, would Yao Ming's z-score be higher or lower when compared to his countrymen from China? Interesting. All right, so let me just do this again. Copy and paste. Now, what would happen if I put Yao Ming versus China in here? That way we can kind of tell the difference. Okay. So what would happen? All right, so he's still 90 inches tall, but the mean might be a little bit lower. China's not quite as diverse in terms of heights. They still have tall people, obviously, because Yao Ming is from China. So, maybe this might be a little bit lower, say like 68. Okay. What's really also going to happen is that the standard deviation is going to get a little bit smaller. Again, because China is 98% Han, which is a certain type of ethnicity in China, which means there's a little bit less, well, actually quite a bit less of variability. So they do have some tall people and some short people, but it's a little bit less widely ranging. So let's say it goes to like 2.5. And you can see what happens, right? And again, I just made up these numbers. I have no idea what they really are, but I'm sure that they're a little bit smaller here and a little bit smaller here. And that means he's even more unusually tall when compared to his own background from China, his own people. I'll give it orange. There we go. Okay, so I'll do it this way. Actually, you know what? I'm going to paste. No, I better not. I'll just do this. Here. It'll be even larger z-score because the mean in China will be, China should be capitalized, China will be a little smaller than 69.2, and the standard deviation will also be smaller. So he is even more unusual when compared to his fellow countrymen. All right, so that's what z-scores are and what they're all about. Z-scores basically tell you how many standard deviations above or below the mean you are. Can't say it enough. That's what it does, right? Positive z-score will be above the mean, negative z-score will be below the mean, and it's a really important value because it allows you to compare apples to oranges, literally, right? So, a matter of fact, I'm going to put that right here. Z-scores allow us to compare apples to oranges. As a matter of fact, here, I'm going to make a bulleted list here. Right, so standard scores put everyone on equal footing. They allow us, to compare apples to oranges. And I'm just going to say it right now. Positive z-scores mean the value was above the mean. Negative z-scores mean the value was below the mean. 0 for a z-score means the value was equal to the mean. All right, and then we figured out Yao Ming, and we figured out how he would compare to his fellow countrymen, and we are all done with z-scores. Oops, all right, I will see you back here for percentiles.